now talk about some of the state-of-the-art applications in artificial intelligence. So you could think of many of them. AI is not only compelling, it actually touches many aspects of our lives. The first application one can think of is speech recognition, in which we have virtual assistants such as Siri from Apple, Echo from Amazon, Google Now, or Cortana from Microsoft. They kind of help get things done, such as sending an email, making a doctor appointment, finding a restaurant, order pizza or your Uber car, tell you the weather, and many more. So this kind of technology leverages deep neural networks to handle natural language understanding and speech recognition. We are making good progress in this area of research. It's not top yet, but we can still use them for simple queries. They are performing pretty well. But this remains in the research area for now. A second popular application of artificial intelligence is handwriting recognition. For the history, in the mid-90s, the USPS, US Postal Services, got very interested in automatically sorting handwritten addresses and zip codes on an envelope. By the end of the 80s, Yann LeCun, who is an eminent researcher doing deep learning and neural networks, has published a solution using neural networks to recognize handwritten digits on an envelope. The same approach was adopted to automatically recognize the digits on a check in ATM machines. And hence the whole process of recognizing zip codes and amounts of dollars on the checks were completely automated and actually saved hundreds of millions of dollars to society. A popular and successful application of artificial intelligence is machine translation. Machine translation actually existed since the beginning of artificial intelligence. And the historical motivation is the US government actually wanting to translate Russian text to English. Unfortunately, the first systems using what we call mechanical translation or one-to-one correspondence completely failed. Here's an example drawn from the history of AI, in which we have out of sight, out of mind, the expression that got translated into French as invisible imbecile that actually completely changes the meaning of the expression. Machine translations has gone through ups and downs in the literature, and many funding got caught after this kind of incidents that completely mistranslated the text. Historically, machine translation has gone through lots of ups and downs, cut in funding, and so on and so forth, especially after this kind of mistranslations in the Russian text specifically. But today, machine translations become statistical, and we talk about statistical machine translation that leverages the vast amount of available translated corpuses. So let's say online we have access to a lot of text from official governments and also from, let's say, embassies and United Nations that publish text both in English and other languages. And this is a good quality text, translated text, that could be and was leveraged by machine translation systems. While there is room for improvement, machine translation has made significant progress, and we all use it sometimes online, such as machine translation from Google Translate, that can handle today over 100 languages. So if you plug in out of sight, out of mind one more time into this system, you could see that the translation to French is much, much better and is more faithful to the true meaning and true semantics of out of sight, out of mind. So huge progress has been made in machine translation today. So another obvious application of artificial intelligence is robotics. We know today awesome robots such as now Azimo. You could see here Azimo dancing, but robotics has made a really important contributions and important progress in the last years. So robots can be important in many applications such as robotic surgery, household keeping, and also navigation, etc., etc. So there is a lot of progress on that front as well. Another maybe unsuspected application of AI is recommender systems. So you know Netflix recommendation systems, Amazon recommendation systems that leverages collaborative filtering to look into the history of your purchases and the history of other customers to make recommendations. For example, if you buy this video game, then Amazon would suggest other kinds of items, such as customers who bought this item also bought maybe a microphone or another kinds of games. So this is actually at the core of recommender systems to use and leverage the data and learn from it to make such recommendations. Your email system is also enhanced with AI capabilities. There is a spam filter in your email that actually helps sort your emails as a spam or non-spam. And this AI system is actually learning from your own actions. When you interact with your emails, you're teaching this system how to behave and how to sort your emails. So it leverages some techniques such as naive Bayes classifiers and other kinds of classifiers to be able to classify your text or your email text as a spam or non-spam. It could also leverage your existing emails to propose maybe some ads. So your email is also having some intelligence and is using it to make your experience browsing your emails much better. Another widely used and outstanding successful application of artificial intelligence is face detection. So we all use some kind of smartphone to take our pictures of our kids or our family and friends. Whenever we do that, we could see that quickly we have some thing being detected here, which are rectangle around the faces. It doesn't go through the shirts or through the background. There is an accurate and fast way to detect those faces on the picture that is done by a method called the Viola-Jones, named after its inventors Paul Viola and Michael Jones, who wrote a paper about this methodology in a conference on computer vision and pattern recognition in 2001. This has been one of the most successful applications of AI. The Viola-Jones method detects, classifies images as having a face or not based on different features other than pixels. Instead of using pixels, the algorithm will use windows of 24 by 24 pixels to recognize whether there are different rectangle features in them. So for example, this is an example of rectangle feature that actually can help identify the area of the eye separated by the area of the nose, which is lighter in the middle. Another possible feature could be the area of the eyes on the top and the area of the cheeks on the bottom. So we're going to have a sliding window of 24 by 24 pixels going through the image and try to see whether these features are exhibited, this kind of what we call rectangle features are exhibited in this area in order to be able to classify the images. So the algorithm uses also AdaBoost, which is a machine learning algorithm that helps to identify helps do the classification in a boosting way, which we will see in the next lectures. Besides this representation, the algorithm also uses boosting algorithms, and specifically the AdaBoost machine learning algorithm that allows to focus on the area of interest in which there is a likely face rather than the background, for example, of the image. It has been very successful to do that. This method is very successful. It fails sometimes when we have some problem with luminosity or orientation. For example, this person here has a hat which covers most of the eyes and part of the nose, so the feature patterns that actually tries to identify different rectangles in the face fail. And same thing for this person here that has his head a little bit on the right side. So but in general, it's doing a great job. It is accurate and fast, and it's embarked in many face detection systems. Another area in which AI is making also a good progress is face recognition. It's not a completely solved problem yet, but it is a very good progress being made. In face recognition, we try to identify people on a face, not only whether they exist or not, or detected or not, but we want to be able to identify who is who. But this is actually prone to error because there would be different illumination, different pose. The person could be smiling or not, could be in the morning, on the afternoon, wearing glasses or not, turning left or right. So there are so many variations that make face recognition challenging, but as I said, good progress is being made in this area. Remaining in the vision topic of AI, there have been significant progress in medical imaging, such as detecting breast cancer in mammography images, and many more applications that require imaging of the body, the brain, and the bones. Adversarial search or games represent an important part of AI because it is challenging and because human has always wanted to create computer program or intelligent machine that plays against humans. An example is the chess game. In 1997, Garry Kasparov, the world champion of chess, was defeated by Deep Blue, the IBM machine that was able to use and leverage powerful search algorithms to win the game against Kasparov. Another example is Jeopardy in 2011, in which a human plays against IBM Watson in Jeopardy. And IBM Watson was the winner of the game and leveraged natural language understanding and information extraction to answer the questions. This is the first time where the machine not only used search algorithms and used its computational powers against human, it also used some natural language understanding of the questions and digging into the resources online to get information and answer the questions. A last remarkable event this year regarding AI and games is when Lee Sedol, the world champion in Go, which is an ancient game, was defeated by Google AlphaGo in a match in which the Google AlphaGo won 4-1. It leveraged deep learning, reinforcement learning, and search algorithms to complete the search for the best moves, assuming that here we have actually a complicated search problem because the branching factors or the number of possible moves exceeds 300. So it's a complicated search problem for AI, and yet AlphaGo, leveraging a combination of these techniques, was able to defeat the world champion in this area. Last but not least in the series of AI applications is autonomous driving or self-driving cars. So it has been a dream for a long time, but the dream is starting to become true. It's personally my dream to get into a car, not worry about the commute time and driving, and just relax and have a cup of tea and read. So the area is flourishing thanks to the advances in technology, in sensors, etc. And it's also flourishing thanks to different challenges that were done by DARPA, such as the DARPA Grand Challenge, in which self-driving cars has to drive 132 miles in 2005. The winner was Stanford. 2007, it launched also the Urban Challenge that was even more challenging for cars, and it ended up with the winners were CMU. And finally, Google Car is also becoming reality in 2009, where Google started getting interested in self-driving cars and designing those. So the dream is not far. Maybe, I don't know how many decades we would need to wait, because there is a big change and shift in our mindset, in our thinking about how we interact with cars. There is a lot of logistics and policy that needs to be looked at in order to make this really happen, and switching to the self-driving cars era. I just went through a large number of AI applications. There are actually, AI is all over the place. There are also other applications that actually I didn't talk about, such as fraud detection, web search engines, social network analysis, route finding, protein design, document summarization, transportation scheduling, information extraction, and so on and so forth. And there are many, many other applications that could be actually leverage AI capabilities to make our life better. Information extraction in search engine leverages the billions of web pages out there and can bring us in a blink of an eye the set of a ranked list of possible interesting results for the query that actually uses algorithms such as ranking algorithm, Google Rank, and its variants to get this kind of information. So it is another kind of application of AI that we all use pretty much on a daily basis.